Good morning, good afternoon, good evening, for wherever you are in the world. Welcome to today's Geomagic Tech Tips webinar. I'm Guy, I'm the product marketing manager for Geomagic, and today I'm joined by our Geomagic veteran senior applications engineer, Stefan, based in Europe. Today, he is going to be taking you through a complete Design X workflow, showing how you can reverse engineer a full turbine, pump turbine in less than 30 minutes. A few housekeeping bits before we get started. If you've got any questions as we go through the webinar about Design X, about anything that you see in the workflow, feel free to drop them in the questions panel on the GoToWebinar control panel, and I will make sure that we pose them to Stefan at the end. But without further ado, I'll pass over to you, Stefan, and you can take it away.
Thank you, Guy. Good afternoon or good morning, everybody. Welcome to this tech tip. Today, as Guy told you, we're going to make a reverse engineering of pump turbine in few minutes, maybe less than 30 minutes. We're going to see how it works. Of course, I've prepared this presentation. I don't have the time of scanning inside, so we will start straight from the scan, which is not necessarily perfect, but we are going to see that in a minute. First, I will just jump and switch to Design X. Today, I'm going to use the latest version of Design X, which is Design X 2023.2.0. That get the latest release and the latest update on the software, including the autosave or auto recovery option. And then from here, I'm just going to input or import first the cloud or the scan. So of course, here I'm just importing an STL file. It can be also a cloud or whatever, but here is just an STL file. And first of all, when you get the file, you just try to look at the points and look at the definition, or if there is any problem in the file, you can see that the scan got some problems, got some holes, because this is a real scan. And here we got some problems, some issues, and we just have to take that in account when we're going to make the process of reverse engineering of that part. You can also see here that I have a groove here. It's not really nicely scanned. So we'll try to get that in account, take that in account in the process. The first thing I need to do here on that part is maybe go on the top view. So either with the shortcut Alt-1 or just by going here and going to the top view or the side view or whatever view I would like to have. And I can see that that part is not aligned at all. So I will need first to align that part in order to put it in the right coordinate system in order to make the best reverse engineering process I can. To do that, I will need maybe to extract regions on that part. So first of all, I will hide the axes on the planes. And then here I will extract the regions on the part. So for those who know Design X, it's straightforward. And we go from the left to the right on the Home tab by first importing the file or scanning the file. And then we go from left to right in order to get the right process. So we just imported the file, so we don't need to scan it. We have directly polygon files, so we don't need to run scan process to clean up points, or we don't need to modify points also. We don't need to heal points or heal polygons because we're going to work on the file like this, so we don't need to clean up points. But now we need to extract regions. To do that, I will just launch the auto segment functions. And as I got some problems on the cloud or on the mesh, I will put my sensitivity almost to the minimum. Usually I use 5, and I will press OK for the software to compute the regions on the part. So it's going to take few seconds. Usually it's less than a minute just to compute all the different areas on the part, and then I will decide to modify it or not. So it will take a little bit more time here, and at the end, I got all my region that appears with the total random colors. So you can see all the random colors here. I prefer in the software to switch it to the geometry type, which is here and at the bottom over there, geometry type, which tells me what kind of features the software found. So here it found the freeform, because maybe it doesn't find the revolution, but here on the bottom it found the revolution. And the type of geometry the system found here depends on the accuracy I'm looking for. But the issue here is that you can see that this area, well, this region, includes those areas here, but it didn't take that one or that one or that one and all around. So I would prefer to have all those regions at once. So I will just need to select those regions along with the main one. So I will just add the selection to those regions with the Shift key to add. And then at the end, I will tell the software to merge everything I've selected as one region. It's not really necessary, but I prefer to use that way of working, because like that I can see what data I used in the software. So here I selected all the regions I would like to add. And then from that, I will just go to region and merge. So the software will merge all the regions together in order to get the main top area. If you forget one region, like here, you can do the same process, add those regions. Even though I missed that one, I don't really care. And I will again merge all those regions. So now I got one region here on the top, which is now the software find it as a revolution. Again, the type of geometry the system finds here depends on the accuracy I got right there on the regions. In the tolerance, if the software finds a revolution with a 0.1 millimeter accuracy, it will define it here. And this is really dependent on the scanner's type you're using. So I got that shape. At the bottom, I got that shape. Overall, all that should be a revolution. So as this part needs to be aligned to the main coordinate system, I will just ask the software here to extract a feature, which is not going to be a plane, but it's going to be a vector. In the vector here, in the method I can use, I have a lot of options. Along with, I got revolution axis. So I will ask the software to find the revolution axis, or the revolving axis on that part. And where on that, and maybe also on that one. Well, the software merges them automatically. And I can press preview to check whether the software found a right revolution axis. And I can press OK to extract this axis. So now this axis is done. Maybe I can also use, well, that's the axis. I need a plane to define my origin. Maybe I can use the plane which is defined in this area, or a point over there, or maybe I can extract the minimum point in this direction. So to do that, I will extract a plane, and I will ask the software to extract here the extreme position. The entity is going to be the mesh, and the direction is going to be the vector. You see that there is an arrow pointing down here, which means that the software will try to find the extreme position in that direction, and not the other one. If you prefer to have the other one, you can switch the direction. And I will click on preview, and so the software finds automatically this position. And OK. Now, I got my plane and I got my axis. Of course, I hidden those entities, so I cannot see them. Now I will redisplay all the planes, which are the main planes I can hide, and the main reference vectors, I can hide the basic vectors I got on the screen. And now I got my main plane, my main axis, and I can align that part to my main coordinate system. If you look closer here, as I display the cloud or the mesh as entity type, I can see here I got a plane. So that will help me to define my last plane for registration in order to lock the position of the part. So again, from left to right, I built here the regions. Now I will make, and I built some geometries. Now I will make interactive alignment. The software asks me, what do you want to align? Okay, that's my mesh. And do you want to add also some features? Like if I have probed some features, I can bring them together. I don't really need to add features here. So I will just press next. And I will define in XYZ my orientation. Why XYZ compared to 3 to 1? Because 3 to 1, you define your 3 basic elements here. I want first to define my origin. My origin, I really want to have this origin defined by this axis and that plane. So here you can see that if I turn my part, all my translations here are grayed out, which means they are locked. Everything is locked, my origin is locked, only my rotation are free. Then I will define the z-axis. So z-axis, it's going to be either the axis here or the plane there, but they are constrained together. So if I click the axis or the plane is the same, I just make sure that when I click that my vector is pointing up. And then I will define my last information, which is going to be the y-axis. And y-axis, it's going to be that plane. So this is this plane or that plane. I don't really care that that plane is not exactly in the middle of the part, because it's going only to lock the last degree of freedom, which is that one. So that one that turns around the axis. So if I select that plane, it will just constrain that direction. And I press OK. Now, if I go back again on the top view, you can see that the part is aligned. The part is aligned, and if I look at my tree here, I built to do that a vector on the plane. Those two features were nice. If I click on the vectors here and I look at the properties, the system tells me that this is a z-axis because it's 0, 0, 1 in direction. I don't really care about the position. It's 0, 0, which means that the difference between that vector and the z-axis, it's only the position in z. So I don't really care about that vector. And that plane, it's XY plane. So I don't really care either. So I can get rid of those features. There is no history on the software until you start to build your resolution, extrusion, and so on. So your parametric model. Now, you can see that I got my parts, and I will be able maybe to create the main shape of that part. Here you have 3 shapes. You have the main body, you have the blade here, and the blade there. And then you have also different operation on that. So to create the main body, you have different options. Either you can create a sketch, or you can ask the software to help you to build that. So in this exercise, you will see 3 types of sketches that can be done on that part. So the first one here is going to be the revolution wizard. Revolution wizard, the target is going to be that region, and also I will take some region in between. So for instance, that one, just to get the connection between top and bottom. So that one, no, not that one. I will remove that here. So I can take 3 or 4, and then I will ask the software to get a custom revolution axis. I will ask the software, can you tell me what is the custom one? I click here, and the software tells me that is the z-axis because I aligned my part before, The software sees that the revolution axis is dead. And I will ask the software to make a solid insert. Next, so the software here builds everything for you. And I just see that I just forgot the bottom of the part, so I can go back and tell the software, okay, I want also to add that on the revolution. And again, I will press next. So here you can see the definition of your part, and I will press OK. This definition, it's not what I call the black box, which is something you built and you don't have access to it. If you look at your tree here, the software built for you a sketch and revolves. So if I edit my sketch and I switch my screen, you can see here all your definition for that part. And you can see that this is not right. The software didn't get any information there, so it continued the circle. I will just build here a line from here to there, tell the software that this line is horizontal, and then I will trim that in Power Trim. I will trim that and that just to get the connectivity. And also I'm just checking that I get tangency everywhere. Here also, it's not right because the software didn't understand what to do. It was so thin that I will just create here a line from here to there and magnet my line. And then I will trim in corner trim that line and that line. And to finish with that, I will just look at this area. So this is all wrong because, well, I didn't get enough information in that area. So I will just remove that and create a real fillet from here to there and adjust my fillet radius by editing the value and put the value of 6.5. Right, I just missed this groove, which is not really well scanned. So I will just put a groove here, magnet the groove on top, magnet on the bottom. You can see the size here, get some dimensions on that groove. So here, I will just round the value to 10th of millimeter and put the start of the groove right here. Now I will be able here to trim my parts, trim my sketch by just going on trim and power trim and trim that. Of course, I removed the area where I got the dimension, so I need to get it back here. And okay. Now my sketch should be good enough so I can exit the sketch and right mouse click and make revolve. Automatically the software builds the revolving parts. And if I display the model, I can check if this is accurate enough. So here you can see that it's accurate enough. I can always play a little bit with this area if I want to, but this is in a green area, most of it. Now I will go back here and I will now work with the blades. So I will just display my mesh and I will create a blade close to the plane I have my parts. So here I will just display my ref planes and I will create a blade close to that plane because the plane is defined here for the revolve, the complete revolve. So I will just ask the software to make a 3D the mesh sketch on a revolve rotational method. Central axis is going to be the Z, so it's going to be a revolution on that. And the base plane is going to be that one. But I don't need to make a cross section. I just need to get the outside shape of that blade. So instead of having that, I will take that arrow and ask to have a silhouette of here 20 degrees on that side. So the software computes that, and you can see the outside shape of that blade. And okay. Now I can switch it and I can just create a line here. Okay. And I will create a line vertical and I put the point right there. And to finish with that, I will create a little segment there and I will lock those positions at the beginning and the end just to have a complete definition. And now I need to make this shape. This shape is important for me. So I need to be kind of accurate. So I will start here, go there, and finish with the connection. I know that I didn't make a good job here. I will just need to make tangency everywhere. So from here to there, I need tangency. And I will bring it back together. Now I need to have that accurate the outside. So I will just ask the software to show me the deviation. I will increase the scale, and I will play with those values to have something more accurate on the beginning and the end, and also the midpoint to have something good enough to be within the accuracy I'm looking for. So here it's okay. And that one, I will play a little bit. And of course, you decide where you want to stop in terms of accuracy. Okay. All right. At least with that one. Okay. All right. So you can play here and have exactly what you want. Okay. So now it's okay for me, that accuracy. And then I will here just show the previous sketch and get back whatever value I have here. So I will just extract here or convert that and those values just to get the shape right here and hide that. And then I will trim my sketch. So from here to there. So corner trim. So trim, corner trim from here to there, and from here to there. And the last one right here. So I got the complete shape of that part here. And I can exit the sketch. Right mouse click, revolve. At this time, I will not make a full revolve. I will make a mid-plane by 120 degrees, for instance. And I will not merge those to the rest. I will just display that and display also my model. So I will make maybe that blade. I will hide that and I will make that shape by a freeform surface. Before doing a freeform, I will just arrange the orientation of the face, so the isolines definition, and ask the software either to make, a number of control points or by deviation. So here I will try, I prefer to use control points definition here. And then from that, I can ask the deviation from body. So this looks okay. I just have one little point and press OK. So I built that surface. I can do the same on the other side. So right here, a fit surface, and add some areas. Press next. Of course, again, I can check the accuracy to see if it's okay, and define it if I want to, or validate the surface. So now I can see my two surfaces, and now I will be able to trim or to cut those surfaces. So cut. The tools are going to be the two surfaces. The target body is going to be that one. Next. And I will keep the middle shape. Of course, I will hide those surfaces, and I will not keep that shape like that. I will just add the software to make a full face fillet. Left side here, middle side there, and right side on that area, and OK. All right, so that is one blade. Now I will make the other one. So it's going to be roughly the same process. I will do again a mesh sketch. Again, rotational method, the axis still Z. The axis here is going to be, the plane is going to be here. And I will again take a little thickness, but that time I would just need to have that line. So I don't really need to be very far. I just need to have that height and okay. From that, I will not redo everything I did before. I will just convert the previous sketch. So it's going to be sketch 2 and okay. So I just get everything I got on sketch 2 and I will just create a line here. Of course, I can make sure that this line is horizontal and I will trim that to that and here to there. Of course, I can power trim all the rest. So get rid of that and okay. So that is the definition of that blade and exit. Again, I will make right mouse click, revolve, solid, again mid-plane, and ask again 120 degrees without merge. And if I display my solid bodies and hide the previous solid bodies, okay, I can see here I can see the two bodies here on the part. So I will again display my my solid body and maybe make that those two surfaces. So I will hide the solid body, right mouse click, mesh sketch. Again, I will arrange my isolines and next, and again I can check if the accuracy is good enough. So you see it's all green because it's within 0.1 millimeter. I can do exactly the same on the other side. So that one is a little bit more bumpier. So I have to make sure that I take every single area. And I don't need to be very conservative sometimes on the shape. And I just press next. So again, here, I need to take only one side. Okay, so that's the surface. I just see that I forgot to arrange my isolines. That is something very important, usually for the shape, and okay. And again, I will display my CAD, my solid body, and my two surfaces that has been built right here. And I will do again as before. So I just need to make sure that this surface is big enough. Okay. And as I did before, I will make here in model a cut using those two surfaces and the target body here. I will keep only the middle one. So this happens only when I get a little error when the surface is not big enough. My mistake. Okay. And then I will cut. So with using those two surfaces, I will cut this solid body and I will keep the middle section again. Now, I don't need the surface anymore, so I will just get rid of those surfaces. So delete surface bodies or delete body. All those four bodies here, surface bodies, and I get rid of that. It's a parametric feature. And again, I will hide my solid body and make a full face fillet on the top. So you see that before my surface were a little bit awkward, crossing each other because it was not intersecting. It was above or outside the part. And here I will just make a full face fillet. Here, starting here, the center is going to be there and the right side is going to be there. And okay. And to finish with that part, I will just here show all my solid bodies and add the software to make a pattern on those two bodies. Here, rotational axis is going to be the Z one and 8 instance on the part. And okay. And that's the part I got here. I can always deviation to body, check the accuracy of the parts, and get exactly the accuracy of that model. Okay. All right. And of course, if you really want to go at the end, I can always create here a plane, extract the plane here, and then make from that a sketch, mesh sketch, using that plane a little bit above. Okay. And create here a slot. No, rectangle. And okay. Exit and make sure that this slot is going to be extracted on the part like that. All right.
Great, thank you, Stefan. Super interesting. It's amazing how quickly you can get to a CAD model from the scan data. Does anyone have any questions while we've got Stefan here? Any questions, make sure to drop them in the question panel on the GoToWebinar screen. Can you please explain XYZ?
Oh, so in the alignments, XYZ, when I'm doing the alignments, it's just when you, if I just hide my model here, in the alignments here, XYZ is you define your origin first, so the zero of your parts, so the position of this datum, and then you define two axes. As in 3-to-1, you define your plane, vector, and position to define the 3-to-1 alignment. So you get the origin at the end by intersecting all the entities here. I prefer to use XYZ because you can really define your origin at the beginning.
Great. We have a question here. Did you combine all the solids at the end, or are they still
No,
separate?
I forgot. I forgot, but yeah, it was just here a combine. Oops, Boolean, Control A, and OK. I forgot.
Perfect.
So now I got one solid body I can export.
Great. We've got a comment here about where you can go to get more information about these kinds of workflows. So this webinar series that we host on a monthly basis is focused around specific industry workflows and specific tools within our Geomagic portfolio that are going to enable you to work through those workflows. So if there are any specific ideas or any specific workflows that you'd like to see, then please reach out to us. I'm going to put the email address in the I'm going to put my email address in the chat. So if you have any requests, or if there's anything you'd like to see, or if you have any questions for Stefan, then you can absolutely reach out to us.
Okay.
We have one more question here. What features have been added to Design X 2023?
The feature that has been added in 2023 is the tube. So if I go here on Design X, which is a nice feature, find the example. I will find one. So the tube is going to work very nicely on your parts in order to get some pipe management. And this is on the models here, and you got two new features. The first one is a 3D polyline curves that defines usually the pipe wizard. No, I think it's not too. I need to find. Yeah, that's the one, I think. Okay, that's a nice pipe here. And if you want to make the definition on that, you use the pipe wizard. You just click here on the pipe. The software will select automatically the pipe, and then you press next. So right now it's same as before. The only difference here now is you can ask for lines and arcs, and now it creates a nice pipe definition with a value you write in the pipe. And here you have all the lines and curves each time. You can ask two cap ends to make a solid body. And when you press OK, you have the new feature, which is here, the 3D polyline curve. If you edit that, you can see all your apex here. So the point 2, if you point 1 is the beginning, so you have no radius. Point 2 is that one. So the radius here is 100.2 there. It's 79 millimeters. If I want to have 80, I can modify the radius of that one. Point 3 is that one. 77, I can put 75. So you have access to all your apex and all the definition of a tube. That is the main definition. Also in that version, you have access now to this data save mode, where it's going to auto save every minutes your work. And if you crash, because it's a software, sometimes it crashes, it will automatically ask you to recover the file.
I think this that answer kind of leads on to another question here. How is it possible to ensure that you correctly convert? I assume this means to CAD models for specific softwares, so Inventor or SolidWorks.
Well, when you do that, if I open the file, I just did, well, if I, if I take the turbine here, it's another turbine, but well, that's a different one. If I look at that, I can check if this part is going to be compatible with another software. So here, if I ask for SolidWorks, I see that this one got issues. So I missed some entities here. Yeah, I did something wrong there. So here you got some functions, sorry, it's in French here, but you have all those functions which are going to be compatible with the CAD, so SolidWorks or NX. So you have features that will have some issues with the live transfer, like a circular model. It can be exported, but that cannot be converted. So maybe it's going to be better to do that in the CAD software and resume the transfer to the CAD software afterwards. Or some features like that were like delete face. It's not supported in the CAD software. It's supported in some CAD, but not all the CAD software.
Great. And another question here that kind of leads on to that, obviously creating these models in a parametric way with each of the features in the feature tree. We've got a question here about any advice for making this CAD in a more parametric way? I guess how you went about modeling based on the mesh.
Yeah, I think this is regarding the surface I build with the mesh fit. Yes, you can make lines or by section and make a loft afterwards instead of doing a mesh fit. So yes, or you can make also a loft, directly a loft wizard, which is going to be a fully parametric loft. So yes, sometimes we use some freeform features, but it's possible to do it in parametric way.
So if you needed to edit the geometry afterwards, for example, if you move the CAD into your CAD package and you need to adjust the shape of the blade slightly or adjust a fillet or a curve, yeah, right. That looks like all of the questions we've got today. As I said, if there's anything else that you think of that you'd like clarifying, feel free to reach out to Stefan on the technical side. Any workflows that you would like to see in the future, or not just workflows for these webinars, but also tutorial videos and any other content that would make it easier for you to use the software and use various tools, then please reach out to me. I'm always welcome to feedback. We want to make these sessions as useful as possible for you. So really appreciate your time. Look out for our Tech Tuesday newsletter that comes out on Tuesday with the invite to next month's webinar. I think that one is likely to be focused on Control X and inspection. So if that's of any interest to you, then please feel free to join. Thanks very much for your time, Stefan. Really appreciate it. And have a good day, everybody.
Have a good day, everybody.